you may use a graphing calculator. Does anybody need a copy of the study guide? I think I have one left. It's yours, Sawyer. Yeah. All right, so just a reminder that tomorrow will be part 1 of the test, which is all the stuff we covered yesterday, and you've got extra practice problems in Polaris over those 5 types of questions that we talked about: 3 graphs, long division, synthetic division. So what we're going through today is what's going to be on Tuesday's portion of the test, and Monday will be an extra review day in class for you guys to practice this sort of stuff. So but I'm not going to be in here on Monday. There's going to be a sub, and you guys are going to have like little stations you're going to go around and practice with. So I wanted to make sure today we do this together so you can get all your questions answered, and then Monday's just extra practice. Okay. So part 2, graphing calculator. Let's see what we got. Okay, this problem says we are going to determine the coordinates of the hole in the graph. What do we do to find a hole in the graph? First step. Yes. All right, so we got to factor it, bless you, and see if anything cancels. Does my numerator factor? What does it factor to? Perfect. What about the denominator? Yes, we've got difference of squares on the bottom there. So what's that factor to? X plus 3, x minus 3. So, does anything cancel? Should, right? The instructions say find the hole. So something should cancel. That should maybe even give you a clue for the factoring part if you're not sure. Hello. Thank you. All right, so the x plus 3s are going to cancel. So how does that help me find the hole? So the hole is going to be when I set that factor equal to 0, x equals -3. Now it says find the coordinates of the hole, so -3 is the x coordinate. How do I find the y coordinate that goes with that? Yes, bud? Yep, and I wouldn't use the original equation only because I plugged in the original. I'm just going to keep it dark. Stop trying. No, just kidding. I just opened it like 7 times. If I plug in the original equation, we're going to end up with a 0 in the denominator because of that factor. So you want to plug it in to just the x minus 1 over x minus 3 part. So actually, let me write that. Just the reduced version is where we're plugging it in. Okay, so that would be -3 minus 1 and -3 minus 3. So on top, I'm going to get a -4. On the bottom, I'm going to get a -6, which is going to reduce to 2/3. Okay, again, if you plug it in the original equation, you know you're not supposed to do that because it's going to give you an error. Okay, questions finding the coordinates of a hole in the graph. Okay, moving on. Next, create a rational function that has the following characteristics. This problem is like the very last problem on that 3-6 exit ticket that we had, where we have to form the equation, kind of work backwards. Here's some things that can help you, okay? So you want to make sure you have a leading coefficient, an a value. And then everything else in the numerator are going to be x-intercepts. That's where our x-intercepts come from, the numerator, okay? And then what comes from the denominator? Do you remember? The vertical asymptotes are going to come from the denominator. So you can kind of use this as like a fill-in, all right? I'm going to keep that a there for the moment. If I want, let's see, what are my x-intercepts? Oh, I actually only have one x-intercept. That's going to make our life easier. If I want to have an x-intercept at -4, what needs to be the factor up there? X plus 4. Okay. If I want to have a vertical asymptote at 2, what needs to be in the denominator? X minus 2. Okay, I use that, next, I would use my y-intercept. My y-intercept says I have an x and a y. I can plug those in. My y is negative 6. My a I don't know. 0 plus 4. 0 minus 2. Okay. So negative 6 equals, what am I going to have on top? 4a. What am I going to have on the bottom? Negative 2. So negative 6 equals negative 2a. So a is 3. Final answer. F of x equals 3 times x plus 4 over x minus 2. And then the only thing we didn't address, but you can check it at the end, is there should be a horizontal asymptote at y equals 3. The degree of the numerator and denominator are both 1 here, which means I should be able to divide the leading coefficients and get that horizontal asymptote. If I divide 3 over 1, I get 3. So that also checks. Okay, so we plug x-intercepts, or we use x-intercepts to create the numerator. We use vertical asymptotes to create the denominator, and the y-intercept gives me that last little piece. Any questions? Okay. Next, we are creating a polynomial function. This polynomial function has degree 4, leading coefficient of negative 3, and it has zeros at 4, 5 minus rad 2, and 3 minus 7i. Change that to degree 5 at the top there. Make it degree 5. That doesn't make sense. Okay. So p of x equals leading coefficient. What?
Our paper says 4, 2, 3.
Of course it does, because Mrs. Solarcheck must have changed it. What did your paper say?
For degree 4, and then the zeros are 4, 2/3, and 3 minus 2.
I think I'd rather do this one, just so it covers the ones with the i's and the radicals. All right, so let's see here. Let's make it degree 5 on yours. Does yours say leading coefficient negative 3? Yeah? Okay, let's make the 0 instead of 4, let's make it 4/3. That way we have a fraction. This will cover all of our bases. And then we have a 0 at 5 minus rad 2 and 3 minus 7i. Just change it. This will cover everything we need. I had a feeling she was going to do that after I printed them. All right. So p of x equals leading coefficient, negative 3. It's degree 5, which means there are going to be 5 linear factors to start. Okay, and each factor is going to go with a respective 0. So 4/3, 5 minus rad 2. If 5 minus rad 2 is a 0, what else is a 0? Because those guys came in pairs. 5 plus rad 2. And if 3 minus 7i is a 0, that also comes in pairs. 3 plus 7i. Okay. Once I have all my zeros, how do I make them a factor? What was that? Yep. And we're just going to leave it like that, even though it's a fraction. We don't need to FOIL these out in our answer. It's going to say write our answer as a product of linear and irreducible quadratic. So even though it's a fraction, just leave it. It's okay. And then for the other ones, bless you, we're still putting x minus in front, but it's in front of both terms. So it's going to change the sign of everything that we see. So for that next one, it'll be x minus 5 plus rad 2. Bless you. X minus 5 minus rad 2. X minus 3 plus 7i. X minus 3 minus 7i. Okay. Now, the instructions again say write as a product of linear and irreducible quadratics. The first part of this problem is okay. The p of x equals negative 3 x minus 4/3. That's fine. But we don't want radicals or i's. We want to FOIL those pairs together to get those quadratics. And remember, there are two ways to do this. You can either completely FOIL it out, and your radicals or your i's will cancel, and there's 3 terms times 3 terms, so that's 9 terms total. There was also the shortcut that we practiced. I will tell you, sometimes people try to use a shortcut, and they use it very badly, and it doesn't go well. So when in doubt, just do your FOILing like you know how to do, okay? It takes a minute, but you'll probably get it right. All right, so let's say I want to FOIL these out. Everything in the first parentheses times everything in the second parentheses. That's an x squared minus 5x minus x rad 2. Negative 5 times everything in the second parentheses is negative 5x, positive 25, and then positive 5 rad 2. What's the matter? Rad 2 times everything in the second parentheses will be rad 2x, negative 5 rad 2. And then negative, what's the square root of 2 times the square root of 2?
2.
Just 2. If you multiply a square root times itself, you get the number underneath. But one's positive and one's negative. That's why we get a negative there. Okay, so if I multiplied like rad 3 times rad 3, it would be 3. Or you can say square root of 4 and then simplify it. But all right, and then if you're doing this right, anything with a radical should cancel. So positive and negative rad 2x. I have a positive and negative 5 rad 2, and you should be left with a quadratic. X squared minus 10x, and then I have a 25 and a negative 2, so a positive 23. And that's what we call an irreducible quadratic. I can't factor it over rational numbers. Okay. And then we do the same thing with the i's now. Again, you can use the shortcut if you want, or just FOIL. If I FOIL x squared minus 3x minus 7ix minus 3x again plus 9 plus 21i plus 7ix minus 21i minus 49i squared. And again, if you're doing it right, anything with an I should go away. So I've got positive and negative 7ix, those are gone. Positive and negative 21i, those are gone. And what does I squared simplify to? Negative 1. So instead of negative 49i squared, I can write what there? Positive 49. So quadratic is x squared, negative 3 and negative 3 give me negative 6x. 9 and 49 give me 58, and this is where we stop, okay? It's linear and irreducible quadratics. I don't have any radicals. I don't have any i's. That's as far as you need to go with it. In Math Excel, you guys had to do a lot more FOILing, but you don't have to on the test. Any questions on that problem? Okay. Next. All right, so this problem is possible number of zeros. So sometimes people will get confused with this problem and try to actually approximate what the zeros are with the P's and Q's. This is not P's and Q's. If we're finding number of positive and negative zeros, that's Descartes' rule of signs, where we like subtracted 2 until it didn't make sense anymore, changes the sign. Does that sound familiar? That's what we're doing in this problem, okay? So not P's and Q's. That's the rational roots theorem. That's something else. It'll say rational roots theorem. All right, so possible number of positive zeros. To figure that out, we just count the changes of sign in the original equation. So the first to the second term, those are both positive, not a change of sign. Second to the third is a change of sign. Third to the fourth, not a change of sign. Fourth to the fifth is a change of sign. Fifth to the sixth, not a change of sign. So there are 2 changes of sign in the original function. So the possible number of positive zeros is 2, or less than that by an even integer. So keep subtracting 2 until it doesn't make sense anymore. So 2 or 0, and that's it. What do you do to find the possible number of negative zeros? Plug negative x in first. So 6 times negative x to the 5th plus negative x to the 4th minus 7 times negative x to the third minus 6 times negative x squared plus negative x plus 2. And then the only thing that should change potentially is the signs here. Remember, you always do the power first before you multiply. Will the first term be positive or negative? Negative. Will the second term be positive or negative? Will the next term be positive or negative? What about the next one? And then negative x, positive 2. Again, count your changes of sign now. 1, 2, 3 changes of sign. So my possible number of negative zeros is 3 or 1. What if I had 7 changes of sign? What would my answer be? Yep, 7 or 5 or 3 or 1. If I had 6 changes of sign, it'd be 6 or 4 or 2 or 0. Okay, make sure you list all those options. Any questions? Descartes' rule of sign. Possible number of zeros. Yes? These do count. Well, no, I take that back. These are, because they're positive and negative, these are x-intercepts only on the graph. So they're only our real zeros. Okay. Other questions? All right. The next one is where you're going to use your P's and Q's. So the rational roots theorem is P's and Q's, and then synthetic division to solve and find all the zeros. So how many zeros should this polynomial have? How many solutions? Blair's doing this. 4? 4 solutions. How do I know there's 4 solutions? Because it's degree 4. So I know I'm looking for 4 answers at the end here. How many times will I have to do synthetic division? 2 times, because we want to get it down to a degree 2. All right, let's start with P's and Q's. Where do P's come from? From the constant term, 1. So factors of 1 are 1. Q's, leading coefficient, which is 2, so 1 and 2. And then all the different ways, which you're not going to have a lot here, that you can do P divided by Q. So plus and minus 1 over 1, 1. Plus and minus 1 over 2.5. The problem says to use the rational roots theorem. So could you go straight to your calculator? Potentially, yes. But if you do not show this work, I will take points off on your test. So make sure you write the P's and Q's down because you're getting points for that, and it's easy, right? Easy points. Okay, next is where we graph in our calculator now. Okay, and I don't actually on the test need to see the graph. I just need to see what you think you're going to try in the synthetic division. So approximately what we think out of these values could be zeros, could be x-intercepts. So go ahead and graph it real quick. And remember, we need to do synthetic division twice. So we want to give ourselves at least 2 options, maybe more. What do we think? What looks good? 1, -1/2. Sound like a plan to start? Okay, let's do it. All right, make sure when you are setting up your synthetic division, if you are missing a term, you put a 0 there. You will get really, really frustrated because your synthetic division won't work if you're missing a term and you don't have a 0. In this case, we don't need a 0. All of my powers are accounted for. And we can try, doesn't matter which one first. Let's say I try 1 first. Okay. So I'll bring down my 2, multiply, add, multiply, add, multiply, add, multiply, add. Okay. So I got a remainder of 0. That's what we want. My first answer is 1. Okay, now what do I do? Okay, do not go back to the original equation. You want to keep making the equation smaller and smaller each time. So we're using our answer, that depressed equation it was called. Bring down, yes?
So only go back to the original equation
if it doesn't work. Yes, absolutely. And if you do go back to the original equation, like let's say I divide -1/2 out, it's going to work, but it's going to give you a cubic. Like you're just going to constantly be going between 4th degree, 3rd degree, 4th degree, 3rd degree, and it's never going to get small enough, a quadratic, that you can solve. That's why we want to just keep making it smaller and smaller, okay? 2 times -1/2 is -1 plus -5 is -6 times -1/2 is 3 times -1/2. This isn't working. Uh-oh. Okay. Let's see. We got another option. What about +1/2? Maybe? Do you want to try that? All right, bring down my 2. Times 1/2 is 1. It's -4. Times 1/2 is -2. Times 1/2 is -1. Ooh, that's better. Okay. -1/2 is close, though. All right, 1/2 is my second answer. All right, what am I left with now if I had a degree 4 and I did synthetic division 2 times? Degree 2, put the x's back in. 2x squared minus 4x minus 2 equals 0. You could even simplify this one a little bit by dividing everything by 2. Make it x squared minus 2x minus 1 equals 0. Is that factorable? Two numbers that multiply to -1 and add to -2. No. And I can't just get the x long because there's 2 x's. Can't use square roots. So what do we have to use? Make sure you know your quadratic formula for this test and every test after. X equals. All right, opposite of E. So +2 plus and minus square root B squared, 4, minus 4 times A is 1 times C is -1. All over 2A, 2 times 1. Okay, make sure you know that formula. Underneath my square roots, I'm going to have 4 plus 4, so a rad 8 over 2. How do I simplify that? Can we break down that radical? Square root 8. What perfect square divides into 8? 4. Think of it as square root 4 times square root 2. So I can reduce it to 2 rad 2. And then everything there is divisible by 2. All the whole numbers are divisible by 2. So I end up with 1 plus and minus 1 rad 2, which usually we don't see the 1 in front of it, all over 1. And those are going to be your last 2 answers. 1 plus rad 2 and 1 minus rad 2. If you wanted to check these, you could type these in your calculator. If I do 1 minus the square root of 2, I get -0.41. That's what we were thinking was that -1/2. Okay, so you should be able to see if you get the decimal approximation for those. the other locations that you're crossing the x-axis that we didn't already have as solutions. Yes?
If you just like simplify all the way, would you get points off?
Yes, I would take off 2 points. And if we didn't reduce this, you would have even more reducing to do here. So either you do it at the beginning or you do it within the middle of the quadratic formula, but you're going to have to do it one way or the other. Yeah. Okay, so we want to make sure radicals are reduced, fractions are reduced, no answers that are not exact. So if it's a decimal that's not exact, just make sure you use the fraction instead. Sebastian, did I just answer your question? Okay. Any questions on that one? All right, the next problem's pretty much the same procedure. So again, degree 4. What are my p's in this problem? Factors of 30.
1, 2, 5, 6.
I think we're missing 2, 3, and 10. There we go. They're not in order, but I'm going to let that go. Okay, Q. Factors of leading coefficient. 1. So P's over Q's, don't forget your pluses and minuses, are just going to be a bunch of whole numbers. 1, 2, I'll put them in order now. 3, 5, 6, 10, 15, 30. All right, so we did the rational roots theorem. We showed our P's and Q's. Now go to your graph, type it in, and let's get some possibilities. Any of those numbers that we think might work. Now on this list, you have some values that are outside of your standard window. So it's possible that you have an x-intercept at like 15 or 30. If you don't have enough in the little window, you can always zoom out to find them. Okay. What do we think? What looks good? -3, 1. Is that it? The other thing you want to look at on these is it crossing through or turning around at any of those? Is it turning around at either of those places? If it was turning around at either of those, what would that tell you? That you could use it twice. Okay, so that's another option if you like run out of zeros, see if you're turning around at a value. Yeah. Absolutely, especially with the whole numbers. That would be a way to check for them.
How do we know that it turns around twice? 4 times?
You don't know that, but you can at least divide it out twice. And for our purposes, that makes it small enough that it's solvable. You could always try it a third or a fourth time. If it doesn't work, it doesn't work. All right, so let's try it. I don't think I'm missing any terms here again, so I don't need any zeros for my synthetic division. All right, let's try -3, just because I have that on the list first. Bring the 1 down. -3, -7, 21, 16, -48, -10, 30, 0. Okay, that one's good. First answer is -3 for sure. Now I have a cubic, so I need to keep going. Let's divide 1 in. Bring it down. Multiply, add, multiply, add, multiply, add. Okay, so 1 definitely is another solution. And now I am left with a quadratic. X squared minus 6x plus 10 equals 0. Doesn't factor. 2 numbers that multiply to 10 and add to -6. I can't use square roots because I have an x squared and an x. So again, we have to use quadratic formula here. Okay. X equals. Opposite of b is 6. Plus and minus. Square root. B squared is 36. Minus 4 times a is 1 times c is 10 all over 2a, 2 times 1. Simplify under that square root first. I'm going to have a 36 minus a 40, so I'm going to have -4 under my square root and a 2 in the bottom. When I have a negative under the square root, what kind of answers am I getting? Imaginary i's. What's the square root of 4? 2. So square root of negative 4 is 2i. Just attach an I to it. And then everything there is divisible by 2. So I can make it 3 plus and minus I. So 3 plus I and 3 minus I, which those ones we can't really check. You can't even see them on the graph. Just hope you did your math right, are our last two solutions. Okay, make sure, again, you show all the steps. A problem like this is worth between like 8 and 10 points on the test. So make sure you're getting all the partial credit, especially if something's not working, you're showing all those. All right, questions on the big ones here? Anything with rational roots, synthetic division? Zeros. All right, last one is all of our end behavior for a rational function. You don't have to do this on your test, but I'm going to number these just so we're all looking at the same thing. Okay, there are 6 ends. And then you can mark what the asymptotes are too if you want. Like this guy's at y. I know your graph's a little tiny. It'll be bigger in the test, but that y-intercept, or the, not y-intercept, horizontal asymptotes at -2. And then I have vertical asymptotes, it looks like at -1 and at +3. So that can help you when you're writing your end behaviors to label those. Okay. Each end behavior should look like the following. The limit as x approaches something, and then technically we should put a function notation here. If you don't put a function notation, though, I'm not going to mark it wrong. So you're saying what x is approaching and what the y is approaching. Okay, and that's what all 6 of them are going to look like. 4, 5, 6. Okay. Just leave it like that. All right. So end behavior number 1. What is x approaching if I were to extend that line in that direction? Not positive infinity, negative infinity. And what's the y getting close to? It's getting close to the asymptote at -2 because it's leveling out. It's not going up forever. It's not going down forever. It's leveling out at that asymptote as I were to continue to the left. If I were to continue to the left forever, my x goes towards negative infinity, my y gets really close to -2. And actually, let's jump to end behavior number 6, because that's going to look really similar. On the ends, we get close to those horizontal asymptotes. So x approaches what on the right side there? Infinity, positive infinity, goes forever to the right. And what's the y get close to? Again, -2, the asymptote. Okay, now the ones in the middle, again, we're going to set up the same way. But this time, my x is getting close to a vertical asymptote. So the second end behavior there, one's labeled number 2, we're getting close to the vertical asymptote at -1. If you are getting close to a vertical asymptote, this is the asymptotic end or behavior near the asymptotes you might see in Math Excel. You need to put the little plus or minus notation. So that means we're saying it's on the left side or the right side of the asymptote. And behavior number 2 is on the left side of the asymptote. So we use a little minus in the power there. If you do not put a symbol, a minus or a plus, I'm going to mark the whole end behavior wrong because I'm not going to know which one you're talking about. You must put these symbols when you're near the asymptotes. What's the y approaching? It's going up forever. The y's are easy in the middle because it's either going up or down forever. So the next one, limit. X is still approaching -1, but this time it's on the right side. So we use a little plus. Our y is approaching negative infinity. It's going down. And then the last two, my x is approaching 3 on the left, and my x is approaching 3 on the right. What's my y approaching for number 4 at the bottom there? It's at the bottom, negative infinity. And what's my y approaching for number 5 at the top? Positive infinity. And that's all you have to do for those. Okay, and again, if you don't have the f of x, I won't mark it wrong, but I want to see what x is approaching, and you've got to tell me what y is approaching at each of those. All right, that is what you're going to say on day 2 of the test on Tuesday. All right, so tonight, you're studying for part 1. You also have your 3-6 Math XL, but that's not due until tomorrow night, so that's up to you if you want to do that as just partial practice for your test, or if you'd rather hold off and do that tomorrow, that's okay. And then over the weekend, you could just be looking over part 2 stuff, and then Monday, a little extra practice over this in class, extra practice problems, and then Tuesday we'll do part 2. Sound good? Any questions for me? Nada? No? Okay, I'll do cell phone lotto. You guys got about 10 minutes left? You can let me know if you need anything or start looking over stuff, work on Math XL, whatever you want.